Okay, so now this orange triangle's area is 1/2 times A times R, where R is the radius of the inscribed circle. You see, in this triangle, A is the base and the inscribed circle's radius is the height. And similarly, the blue triangle's area is 1/2 times B times R, and the unshaded one is 1/2 times C times R. So if we add all three together, we get the area of the triangle, and it's 1/2 R times A plus B plus C, which is the perimeter. And so that means that if we know the perimeter and the area of a triangle, we can find the inscribed circle. And let us just remember that if the triangle is right, or if the triangle is isosceles, then we can find both the area and the perimeter pretty easily. So 2A over the perimeter, 2A over P is the radius. So that's the formula we're going to use for the inscribed circle. We're just going to have to do a little bit of work for the area, right? The three sides are 12, 20, 20. And for the area, we will need this height. We're going to use the Pythagorean theorem. The height is going to be, notice that 20 is the hypotenuse. So the height is going to be 20 squared minus 6 squared under the square root, 364. 400 minus 36 is 364. Would that be a square? No. Okay. So then the area of this triangle is 1/2 times, common mistake to use the base 6, but really the base is 12, right? 1/2 times 12 times the height, which is square root of 364, which is 6 times square root of 364 under the square root. Okay. Now I want to start dragging out things from under the radical, because we have an expression complicated enough, so there is a multiplier in front of it. Now we can sort of make the numbers nicer if this number stops being all that large. So we have 4 times 364 divided by 4. Square root of 4 is 2. 6 times 2 is 12. So that's the area. And so the radius is twice the area divided by the perimeter, where twice the area is 24 times square root of 91. And the perimeter is 20 plus 20 plus 12, 40, 52. And they asked us about the approximate value. But then again, this way, we don't have to clear the calculator and re-enter something irrational. We're going to have it in the calculator to a pretty good precision. So this is now square root of 91 times 24 divided by 52. And that's approximately 4.4028 units. So what we had was 4.4028, and it's right. Okay. All right. Now let's see for the circumscribed circle. So the formula we're going to use is a pretty simple one. It is our triangle ABC, and this angle, which we're going to call gamma, this angle is an inscribed angle belonging to this arc, to the same arc. This is a central angle. And then this is an isosceles triangle because we're in a circle. And so this line is a symmetry line, an angle bisector, and also a perpendicular bisector. And so this angle is gamma again. This is then C over 2. So in this right triangle, sine of gamma is C over 2 over R, or C over 2R. And then we multiply by R, divide by sine gamma, and we get that R is C over 2 times sine gamma. Takes about 10 seconds to derive it. Now, we don't know any angles, but we can get the angle because this triangle is isosceles, right? If this side is 20, that side is 20, and the base was 12, then we have a right triangle here where I'm going to call this angle alpha. Sine alpha is 6/20 or 3/10.3. And so alpha is the inverse sine of 3/10. Now what we need, this angle, is twice that. So our radius is going to be, the side opposite the angle is 12 divided by 2 divided by sine of 2 alpha, where alpha is this. I think we can just punch in the whole thing. Let me just simplify here. Sine of 2 alpha. And while we're at it, I want to show you a neat little trick with the calculator. It's a time waster to clear things and re-enter, especially if you require precision. There's a way to make the calculator remember important numbers. You can store up to 5 numbers in this calculator. So we're going to first compute that alpha, and then we're going to store it in the calculator. So this button here, the white letters, STO, that stands for store, and it's not visible, but RCL with light blue is for record. So we're going to say second sine 0.3, 17 degrees. And so our angle is twice this. So just to be on the safe side, I'm going to store this. See, I have 5 empty spots. So I'm just going to go and select A. And now the answer 17 and change went into A. And now I can clear the calculator. And if I need to recall it, I just go second store, which is recall. And then I can see B is empty, C is empty, but A has my number. All right. So that will cut down on work and danger that is involved in button punching. All right. So we're going to have 6 divided by sine of 2 times equal A. Now, this is the only annoying feature that you don't see the beginning of the number. It is, but I need to see the parentheses. So that was just one pair. We need to close that one. And so we got 10.4828 units. And then we check. So we think it was 10.48285. So ours is a little bit more precise than, yes. So we got it right. Excellent. Thank you for watching.